Hello viewers and welcome to another Minecraft Redstone video with me, Redstone Paradox. In today's Redstone video, we are going to be looking at this circuit. This circuit right here. Now, you see comparators, hoppers, repeaters, torches, blah blah, pretty much every redstone component, but what exactly does it do? Well, this is a circuit or logic gate, though logic gates are traditionally binary and this is not. Anyways, this circuit takes an input signal strength and compares it and outputs an on pulse output, or whatever you want to call it, if it is between those two numbers. So anyways, currently I've got the lowest number set to 13 and the highest set to 15. So if I put 15, nothing happens. If I put 13, nothing happens. And hold on, 15 since I didn't show it. If I put in 12, nothing happens, and so on and so forth. But if I put 14, which is between 13, our lowest number, and 15, our highest number, I get an output. So how this works is, first it takes this input and subtracts it. It takes an input from here and subtracts it from the input in here. Now, if the input is less than the number here, which in this case is 13, and when I say number, I mean signal strength. Obviously, there's way more than 13 iron in that hopper. If this signal strength is greater than this one, only then will it output a signal, turning off this torch and then turning on this one. Now, if you're wondering why I don't just take the output from this dust, well, you'll find out in a moment. Anyways, on the other side, we have a similar setup. Comparator, repeater, except set to 2 ticks, since this is a 2-tick delay. Repeater and torch, but there's no torch over here, so we have to set 2 ticks. Anyways, as I was saying, over here, rather than have the comparator in compare mode, rather than have the comparator in subtract mode, we have it in compare mode. And that's because if it were in subtract mode, it would not output a signal even if this signal strength was equal to this one. So, but this way it does output signal strength if it's equal and greater than or equal to this one. Sometimes my words just fail me. Anyways, so you probably noticed the pattern already, but for those of you who do not, greater than or equal to on this side of this number, greater than or equal to this number on this side, and less than or equal to this number on this side. And this allows us to have an output only when it is between this number and this number. Because if it is less than or equal to that number, it does not output, and if it's greater than or equal to that number, it outputs. Now you're wondering why I just said outputs instead of not output, but if this side has an output, this torch will be turned off, which is why we have the NOT gate, because if we simply ran the output into this directly from the comparator or the repeater, this would be turned off even though we want it to be turned on when it's greater than this number. So yeah, and one last thing, of course, about this circuit is that if you extend both sides by one repeater or comparator, but repeaters are cheaper, then you can actually have a variable input for all three. So right here, as you can see, I have both sides set to 0 actually, which means nothing happens. But if I set this side to 13 like on that side and 15 like on this side, as you can see, 13 doesn't give an output, 15 doesn't give an output, but 14 does give an output. But of course, if I were to say set this lower one to 12, then I could take this, change it to 13, and I still get an output because 13 is in between 15 and 12. So 13 gives an output, 14 gives an output, but not 15, 12, or any other number. Now, last but not least, if I were to, of course, take this and set to 14, 14 would no longer give an output, but 13 would. And that's pretty cool. And, of course, the best part about this circuit is that having a variable input makes it a lot more versatile. So rather than have lines here, redstone lines, you could say drop in shulker boxes because those can be transported via redstone with their content without dropping their contents. So you could like set something up that takes the signal strength from 2 shulker boxes and compares it to signal strength of the third one. So yeah. But anyways, that is it for today. I hope you enjoyed this video. If you did, please wait a minute. I can't conclude the video yet. I haven't shown you how to build it. So yeah. Anyways, actually this is so pretty much straightforward and you can just see the entire thing in this picture by just pausing the video now and looking at it. Okay, awkward pause over. But anyways, viewers, now for real, if you did enjoy this video, please be sure to leave a like, and if you loved it, make sure to subscribe. This is Redstone Paradox, signing off.